G'day guys, just finished repairing a SD2200. It was quite a novel one. I really perplexed on this one. It totally blew up the front end here, and I've just replaced all the components. And I turned it on and smoke was pouring out of it. I'm thinking to myself, what the hell is going on here? And what I actually noticed is that someone had rewired the coil connector, and they did it completely backwards. So I had basically, it was pumping transmit voltage directly into the receiver. So yeah, but I rebuilt him. He's okay. This one had modifications in it. Had one of our early gain boards. I took that out of circuit just so I could check all the components properly. And yeah, I think the fellow also wants this upgraded to our new boards. So I'm going to arrange to do that. In the meantime, been doing lots of development work. Got fellows waiting for his detector up there. If I can, where is it? Oops. Yeah, there it is, right in the middle there. This one. That's Stan's detector. Stan, if you're watching, your detector's done. I've just got to reassemble it. So it's got all the new control boards in it. It should be a ripper. Now, I've got a fellow from overseas who sent me some pictures. I'll just make sure I can move my tripod over to that computer. Clunk, clunk. Okay. I don't know if this is going to come through very clear, but so he's asked me a lot of questions about what's what on his. It's a GP of some description. What is it? GP Extreme or 3000? It could even be a 3500. But he's got. I'll zoom this in a bit. I think I can zoom that. Oh yes, I can. I'll put it on the whole screen. Okay. He's obviously scratched the paint off his detector, so he's trying to fix it. I don't know if you can see the mouse. Yeah, you should be able to see the mouse pointer. He's got these devices here circled, and that's for the both receive input channels. These are part of the circuit, and they connect just past the not just past, but they connect to the receive input stage, and all they are is inductors. I think they're about maybe 1 microhenry, half a microhenry, maybe too much in one of these detectors if it's running very fast timing, such as if it's got extra modes or anything. It's a 35. I'm thinking for 4500. These are probably about 1 or half a microhenry, and I think very, very low ohmage. You measure it is probably 0.1, 0.2 of an ohm. So there's two there, and all they are is inductors, and they are there to slow down the very fast leading edge of the flyback voltage, so it doesn't blow things up. That's all they're there for. Now, also on here, I've noticed there's something that was here. It's not there anymore. That was a BAV 99 diode, and you can see there that's its ground pin. This one here is normally, I was trying to remember, I haven't looked at these for such a long time, but I think this has an eyelet under the board. That's it. That's the BSS 84. That's a P channel MOSFET that connects directly to the non-inverting input on the AD797. It's funny, I haven't done, I've been doing GPXs and trying to remember back to the, because the GPXs don't use a P-channel MOSFET in this position here. They've all gone to N-channel MOSFETs, so they're using a series N type arrangement to block the flyback voltage and to block the transmit voltage, which ends up on the receive wires anyway, or ends up on the coil. This thing here, that is a BF908. It's a dual gate MOSFET, and that is used to supply bias current into these devices, into the AD797 op amp, whilst the input FETs here are open circuited, so it has no bias back through the coil circuit, and that keeps these in a stable position, you know, so that the input doesn't fly up or fly down. You know, and it has to stabilize when the receiver comes back on. It might cause noise in the receiver chain, but that's what it does. They somewhere in the circuit, I think these might be direct connected, but I know in the GPXs they have a 1000 ohm resistor in series with the device. It basically puts a 1K across the two inputs here. But on the GPs, I think it's a direct connect. Long time since I've looked at these, so that's how it works. The A7W, the same as this one here, that's just the BAV99 diode. Usually they're run as two diodes in series, and it's like through there to the center point, and then another internal diode to this point. That middle leg is not connected. For memory, I don't think it's connected. I'm pretty sure it's not connected. I know in the GPXs it's not, but this one, I'm pretty sure. It's just funny that it looks like a little bit of a track here, but I don't think there is. I think that's just. I'll have to look at the schematic and have a look and see, but I don't think that is connected to that point. I'm just going from the top of my head. I haven't looked at one of these, you know, for probably about 2 years or so. So what else is on this thing? This is the output here. They're just 0 ohm resistors. It looks like they did have it set up as with this, the feedback capacitors here. I think they're either 68 or 33 picofarads. These are just 0 ohm, and this goes off the this pin here, which is pin 6. That's the output from these, and it goes through here and goes off into the 4053 multiplexer. Both of these do, and depending on switch positions, it either adds these two outputs together or puts them anti-phase, or just uses one, depending if you're using a double D coil. So yeah, they're just inductors. If you put your multimeter across these, they'll just measure basically near enough a short circuit. So that's that. I don't think there's anything else on this picture. Now, there's another picture here he sent. He's done a good job scraping the paint off the board. He's got this one here circled. I think that is an IRF 455. It's the switch mode power supply driver FET. Any hefty field effect transistor MOSFET will work in this position. From memory, it's an N channel because I think it's positive through the inductor or through the transformer to this, so it has to switch negative. And on the GPXs, be careful. They've gone to a package that is a one like this. You know, one of these 8-legged SOIC type packages, and it's a P channel. It's no longer N channel, so you've got to be careful with that. I've had detectors come in, people have tried to repair them themselves, and they have put an N channel in where a P channel is meant to go, it don't work. It's just a short circuit. What else has he got here? So that's there. So what is this part value? Yeah. So that's basically what it is. That's your gate there, your drain here, and your source there. That there is a low ohm resistor, and that is used for current monitoring, how much current flows through this transistor before it either goes to a turn off circuit if it draws too much, or maybe it's utilized that you've drawn this much, that's as much energy as you can put into that coil, time to turn off and repeat the cycle. Don't know, I never really bothered delving into that, but it's just a current measuring resistor to ground. What else is there? Oh, up here, what is the name and value of this piece? These also are just low value inductors. What would be there? I've never measured them. It's basically on the power supply. You want to see volts there, volts there. You want to see a minimal drop. It could be 2 microhenries or something of that nature. I think 2.2, 3.3. They won't be very high. If the higher they are, they're not very big. They won't be able to handle the current. These things are usually rated for about half an amp. So, depending on how much inductance too. The more inductance, the more windings, the more overall resistance. If it's too much, it'll just sit there and get red hot and melt off the board. So it could be just 1 microhenry. There won't be much. So it could also be a 1 ohm resistor too. They can actually put in like 0.1, 0.2. I wouldn't go up to 1 ohm, but very low ohm resistors you could put in there, and that will cut a lot of interference, depending if they've got really decent capacitors on the other side, which they do. Any stray noise dropping across a resistor, even a low value resistor, into a hefty filter capacitor of, say, on this 1000 microfarads, will kill the noise. A direct connect with no resistance, the noise, high frequency noise, can travel through. This will burn it up, but it doesn't get hot. It's only, you're talking, fractions of a volt. It's not going to do anything. And what else here? Oh, okay. He's got here this. What is the value of this Zenodiode? It is a Zenodiode. Got that right. This is on the flyback voltage clamping circuit. I think this chip here is a 4093 for memory, and it's all floating above ground, this circuit here. There's a couple of NPN and PNP BC series transistors in here. Might be a diode or so. Like I say, a long time since I've looked. I think that's God, here we go. I think it's an 8.2 volt Zener. It's something like that. It's not a high voltage Zener. It's probably just put there to give this floating chip a clamped operating voltage. So 8.2 volts rings a bell. I'd have to get a detector, fire it up, and put a voltmeter across it to see what it actually is. It could be higher. It could be 12 volts. I just don't remember off the top of my head. I think I've only replaced one in my whole life. I can't remember. It was probably 10 years ago. So that's that. What else is there? Okay, these things here. These are just high speed diodes. These are 1 amp, designated UD1, which is an MUR something. Don't know the number, but they got UD1. Just look it up. SMD or SMT diode. UD1. It's just an ultra-fast diode. It's nothing special about it. So don't use Schottkys there or anything like that. Make sure it's a silicon ultra-fast diode. There's another little thing in here somewhere. Where is it? One, two, three, four. I know on some of these detectors. Oh dear me, I don't like going from memory on this thing. There's one of these might not be a diode. Hang on. I'm just going to have a good think about this for a second. One of these, because they changed the design so much, I don't know what actual detector this is. There's differences between the GP Extreme and the 3000 and the 3500 on some of the components. Actually, this might sound. This could be something strange like an 84-volt Zener diode, or as some people call them, Xena diodes. Xena, the warrior princess, but spelt with a Z or a Z if you're American. I'll have to check up on that, but yeah, it will operate without it. It'll actually operate probably with all these diodes removed, but just check to make sure they're not short circuit. These two here are connected in series. I do remember that much. And these are just across the receive inputs, just to help knock off some of that high voltage that comes through. These are reverse connected, reverse polarity to that high voltage. So it's just going to knock off the edge of those. These are input FETs. That looks like it's was one there that melted off the board's been replaced. It's missing some of the track work there, but I'd take it that it's been put in there properly, but I don't know. Yeah, I really actually have to have a look at one of these and just see about that, because I remember the tail here coming down. It could be it's replaced with a part. It's the package is called an SOD143. I do remember that much, and it's much smaller than this one. What else here? What is the value of this? Hang on, I'm going to zoom this in a little bit. It's a little bit hard to see. Can I zoom it in? I'm looking at his email. I don't know if I can. If I can go Command Plus, will that do it? No. Nope. Function Plus? No, can't do it. Can't zoom in on that. I have to actually download it. Okay, this part here, it looks like, what is it? It looks like it's a capacitor, or it could be a chip resistor put in upside down. I would say it's a capacitor. I'm not sure. I've never had to look at this component before by any repairs I've done on these. I've never looked at that. I don't know what that is. Looks like a capacitor, and if it's a little ceramic one like that, it won't be much. It might be something just under 100 picofarads or so. I don't know. I'd have to get one off a detector, and I'd have to go and stick it on the capacitance meter to see what it was. I've got a heap of work on it at the moment, guys, so I don't really have time to go searching and doing all this sort of stuff for free. What is the Zenodiode value of this piece? I don't think that is a Zenodiode. I think that's a normal diode from memory. As you can see, that's a cathode and that's the anode here. But by the sound of it, you got a complete shutdown of the detector by the sound of the fault. I don't think it. Oh, not going to say anything. But what I would do if I was looking at this detector and you're not getting any output. Make sure any of this stuff here is not short-circuited. Anything, even the op amps, make sure they're not short-circuited. If they pull too much current, it'll turn the detector off. It'll shut down. The other thing too, what you should look at, and a lot of people don't realise this, that the negative 5 volts, the clean rails, they actually run clean filtered rails to the input stage, which is very good practice to do. You don't want dirty stuff going into your low noise receiver. But all the components on the other side of the board here have their rail from these two components here. I can't remember which ones. One delivers a filtered +5 and a -5, and for memory, NTM54N01 or something of that nature. They're just MOSFETs. They're just SOIC packaged P and N channel MOSFETs. Nothing special about those. You know, they only have to handle 100 milliamps or so, probably maximum. That's probably too much, but you can stick a big one in there if you want. You can stick a 3 or 4 or 5 amp one. You can put a 10 amp one in there. It's not going to make any difference. Yeah. One the NTM4176 P, which could be a P channel. So there's an N and a P channel there, and all you got to do is look at the supply rails on the other side of the board. You know, where is it? There. If you actually measure the capacitors here, that these are the filter capacitors for the rails on the op amps. You get for memory +5 here, -5 here, and +5 here, ground, ground, right? Oh God. And this one here, one side is -5 volts, the other side is ground. So all you do is I know that's positive, and that's ground. So if you measure there for multimeter on continuity, just get that and measure to that, and whichever one beeps, more than likely is your other ground. So the other one, whichever one it is, can't remember off the top of my head, will be the -5 volt rail. So you want to make sure you've got a plus and minus rail, and you know, if it doesn't work or it's not there, these things have been known to blow up. Now on the other side of the board, these the regulation on these is set by TLE2022. So I think there's I think a TLE2022 is a dual op amp. One's probably controlling this and one's controlling that, and it's just a matter of voltage divider set up on these devices. So I'll put out more or less exactly 5 volts plus and minus. So you can track that to the other side of the board up there. I don't know if they've got test points on here for it. Some of these may be test points. Like I say, long time since I've mucked around digging under one of these boards. Usually you just get the same old common fault on these detectors, and this one's looks like it's a little bit different. Anyway, that's that. And the other thing that's been interesting going on is we've been still doing our I'll turn this around. Dear me. Still over there doing the little ST board over there, hooked up with a 2000, and yeah, just doing some coding for the analog to digital converters. There, look at that. Looks like a hacker. There's a hacker sitting there. He's dressed like a hacker, but yeah, he's sitting there and just trying out some coding techniques, sampling techniques on that sacrificial SD2000 over there. So all good fun. So yeah, been definitely having a good play around. So that's how to fix a circuit. There's a circuit board from another country. Yeah. Whoops, there we go. What's his name? Yildiray from Turkey. There you go. So I hope that helps you somehow with your detector. Just also make sure too, you got all these eyelets. You can see those eyelets here. Be careful if you scrape the paint, because if you break the eyelets or do anything with the plating, you're not going to have voltage. That's a ground for memory. So obviously that's ground, right? Ha ha. That's ground on this one here. You'll have voltage there. And if you look here, that goes to pin, I think it goes to pin 4. This one here is obvious. 1, 2, 3, 4. 4 is your negative supply rail on an AD797. And you can see the track there goes to that eyelet. And I would say there's no track on top that I can see. So, you know, possibly it goes under. I don't know why that's like that. Have to go and measure it all for multimeters. I'm just remembering this stuff off the top of my head, and it's not a good way to do it. Yeah, you see that eyelet there, this one. That's had a bit of a chew around it. You got to be careful that you haven't destroyed that or destroyed this one either. You won't get your voltages to your ICs, and the whole front end will be dead. You'll have to track that through back to those SOIC MOSFET packages to make sure you have voltage there, and to make sure the voltage is getting up. So best way to do that is just put your multimeter on those capacitors and just go back on the other side of the board and just check for continuity. Yeah, but yeah, I will have to revisit this because there's a lot of stuff there. It's probably way back in all my notes, so I'd have to go and dig out of the garage or something. It's a lot of stuff's been put away because these older detectors, you don't see much of them anymore, and because of that, yeah, I don't spend a lot of time. The only other thing too I should mention that will shut the whole detector down too is on these detectors, this big MOSFET here. You can just see it here. Gate, drain, source on the legs. Not that these two resistors here, they are supplying the pulses to the gate. They don't usually go open circuit, but this transistor here is a common one to fail. There's a smaller one behind it which does the 15-volt pulses, but I've never had one of those fail. This big fat thing here, which is a TO247 package, as you can see, is an ST Thompson device, 34NO something, NB. Anyway, what it is, a 200-volt device. 30. I don't know if it's 34 amps, but whatever it is, you could probably clean one up and have a good look at the number there. But they fail. They go short circuit, and that'll pull the whole thing down. That'll shut down the power supply and everything. Always check for that. And also that other, it's not on this picture, but there's another MOSFET there, which is a clamp MOSFET for the 200 volts, drops it down to 185, 190. They fail all the time as well, and usually fail when people. This is something worth noting, that they fail when people have the detector on and disconnect the coil and reconnect coils while the detector is on. It shouldn't. It has all this protection mechanism in with those ultra fast diodes that are meant to stop these high voltage spikes coming through. And also you've got the the input protection FETs there. They fail as well. So obviously, that clamp circuit, it just can't activate quick enough when you're making a coil disconnect, and that can blow up the input MOSFETs, and they go short. Then you get your flyback voltage come through, blows this one here up, blows that one up there up, shorts out some of these diodes, go into conduction. You'll see all these smoked, and I don't think from memory it'll blow up the BF908s. It can, but I don't think it will. Depends on the voltage coming through, but I have seen them. It also takes out one or both AD797s. And if you look at the price of AD797s these days, one-off prices from your mouses and your DigiKeys over there in the US, or even your Element 14 or whoever, or any of these supply houses, well over $20. So don't go blowing these things up. It gets expensive. A lot of semiconductor stuff now is expensive. I look at ordering stuff and I go, my God, you got to pay double from what you last paid. It's really, really bad. The other thing it fails too, you just see on the edge here, this chip here is an ADG 333. It can supply plus and minus volts. It's quite a good little chip actually. It's just a switching chip, switches things on and off. And yeah, that's it. So that's the story with that one. Anyway, we'll leave it there. It's up to date. On to some little updates. What's some updates that's happening? Like I say, the project which we're just using the SD for as a base test unit. It's very basic, simple. The SD. So yeah, we're just using that as just a base switching unit. Just literally just switch. There's that word literally everyone uses. Slap. Hang on, I'm going to slap myself for saying literally. That's our new rule. We're going to slap ourselves when we say that word. And just taking all the switching waveform points and just using it, just basically the first board, not using the audio board or anything like that, just taking the samples out and then sticking it through the Nucleo board and doing some experiments, which is coming along quite nicely. And yeah, been updating quite a lot of detectors lately with the new stuff. Haven't had much feedback from people out in the field, which means usually no news is good news in this game, because if there's something wrong, you know about it damn quick. So, they get out there and they're probably hoovering up all the gold. There is a massive improvement, as you probably see in the previous videos on sensitivity, and that also translates into sensitivity at depth as well. And as you also probably notice, they ground balance really good. So if it's getting rid of the ground and there's no offset in the ground balance circuitry, you'll get gold that is obscured by ground offset. So that's another positive. Anyway, it's enough waffle, and catch us later.